So these videos come out like in three ways. Like the first one is they show us the addition types of problems, and then after that we have some like word problems that really aren't all that involved. That's supposed to say words. My handwriting's really poor there. And then now they tell us to use subtraction. So I guess if we wanted to use subtraction, we would just think of it like this. I see a variable, and they're set up so that they're matching. But all of the deal is if I added them, I would get 14s plus 4t, and that equals 28. And that really wouldn't do me any good at all. I didn't eliminate anything doing it that way. So what would be nice is if instead these signs were all the opposite. So let's just rewrite the problem. Now one thing you can do also, if you really dislike the s and t, you could write x's and y's. And if you do that, just make sure you replace them correctly. And then by the end of the problem, if you're comparing it in the back of the textbook or whatever, just make sure you don't get tripped up. So here's 5s plus 2t equals 6. And I'm going to write 9s plus 2t equals 22. But because this won't work, I'm going to go ahead and I'm going to change the signs on everything. So I'm just sneaking in a negative. It's like I've multiplied everything by a -1. If that's confusing, you can let me know. Here's -4s. This drops out, and I have -16. Dividing both sides by a -4, I figure out that s is +4. Box it, and now let's solve for t. 5 times 4, I'm just putting it into the first equation, plus 2t equals 6, and then 20 plus 2t is 6. Not really a point for me to talk through this because now we're just solving equations, and you've done this. T is going to be -7. And as the final organizational step, we're going to write the ordered pair for this. Now the only reason I left this empty for a moment is because, really, if we want to be conventional and most likely match what we'll see in websites and the backs of books and things like that, we should keep it alphabetical. So here's st is for -7. And when I look up at the problem above in the original equations, if I check those out, they do end up giving me the right answer. Should you end up looking in the back of the textbook and it says -7, 4, it's a way to go back and double check to make sure you have it in the right order and not overthink it or be like, oh wow, I must really have messed up because I didn't have the exact same thing. Be a little bit more trusting in yourself and just realize if it's an order thing, that could be the only mistake. So let's check out problem 2. Okay, so rewrite that, give yourself the pause button if you need to get caught up. And I'm going to write in red, so don't write this for a second. If I subtracted by changing everything in the bottom one, I would end up with a negative down here. And although it's really not necessary to think that far in advance on these, maybe it would be nicer to make this top one negative. My b terms cancel out, and then on the c terms I get a +4c equals -4. I'm going to divide both sides by 4, and I'll get c as -1. Then I have to plug that back in. I'll plug it into the original equation. 8b plus 3 times -1 equals 11. 8b minus 3 equals 11. And then we just solve this. And this is where you're kind of saying to yourself, well, this stinks. I surely made a mistake, because normally, once I simplify these, I end up with something that's like an integer, a whole number. integer or a whole number. But here is the deal. This is correct. So it's not like you'll never be given a fraction. It's just that they're pretty unlikely. And let's look at what happens if I were to plug in that 14 over 8. Well, 8 times 14 over 8, bless you, would become 14. And then this would be minus 3, which is 11. And then the same deal down here. If you plugged it in, you would get 2 true statements, so you know that this is accurate. I'm going to clear the ink for that and move on to number 3. But let's see. Number 3, let's make that an OYO problem. You have 5 seconds until I'll put the whole thing up on the screen. Okay, let me show you some of what I did. To make it stand out, I used a different color to see where the signs were flipped. And that way you can see that the black negative here became a positive. I found out what n was. Maybe the minus signs trip you up as you go through and you try to find m. Not a big deal. But that just means that you have to look here and know that you're either multiplying by 1 or dividing by -1, or just really changing the signs or rewriting it. Now here's m is 2, and because m's earlier in the alphabet, there's the 2, and then I put the -1 next. Big deal, not really, but go through and change it if you don't have it in that direction anyway. And I've already checked the values for m and n here, and they work out, and so make sure that even though it's coming second, that's what we would plug in for n. So you got to make sure that as you do write it in alphabetical order, you plug it into the original equation correctly, and don't think that you were mistaken when you were right. Okay, number 4, we will begin as a team problem and then finish on your own. Pause the video if you need to take time to write it down. Okay, now we've done a bunch of problems where you pretty much can just rewrite them and then just change the signs, and you're good to go. But the issue with this one is things don't line up nicely. And I am completely of the philosophy that if you use a little bit of extra paper to get the work you need done, that's fine. But the guy with which we're happy with this guy because we're used to seeing x and then y. But this, obviously, is the more frustrating one. So let's change this one. And since I usually like to do side work or things that aren't central to the regular steps that we do over here, I'm going to rewrite this problem. X equals 3 minus 1/4 y. Now, the first thing I'm going to do is I'm going to see if I can get rid of all my fractions. And so the number that I'm going to choose to multiply everything by is 4. Because on the right side, if I times 1/4 by 4, my fraction is going to go away. But you have to be careful. Sometimes people will remember to multiply this by 4, but they won't remember to multiply this 3 by 4. Those are 2 separate terms, and the reason they're 2 separate terms is because they're separated by just addition or subtraction. So I'm going to rewrite 4x equals 12 minus y, because 4 over 4 cancels out, and I'm left with just y with a minus sign out front. Now this mostly looks the way that I want it to look, but not quite. So I'm going to add y to both sides, and then I'll get it in this standard form. Hey, Cora. So 4x plus y equals 12. Okay, now that we have these stacked nicely, let's see if you can make this an OYO problem. And there's a little bit of a trick to this. Not a major one, but a bit of a trick. In 5 seconds, I'm going to put the rest of the work up. So, I rewrote the 2 equations, and then these black marks right here are where I changed the signs, and now I have 0 equals 0. And what do you know when you have a true statement? Well, when you have a true statement, that means that you have infinite solutions. Let me write that more clearly. Yeah, infinite solutions. So that means that this is the exact same line. And probably some of you were like, okay, I'm going to just see that they're the same line and write this. But I'd like you to see that just because it helps us remember that when we did the previous section, 5.2, and we did substitution, whenever we found a true statement like 0 equals 0, that did not tell us the same thing as if 3 was equal to 5. When we got 3 equal to 5, that was a false statement. We know there is no solution. So this is infinite solution. So hopefully these feel comfortable, and jump into the practice.